Let's talk now about the next quality of service component, which is marking. Marking means conveying, propagating, bearing traffic type information. Now we are going to divide this session in three parts actually: theory, and interpreting the quality of service configuration, and a bonus uh, part where we are going to talk about DSCP mappings. So if you are already familiar with the theory about marking, you can just jump into see the quality of service configuration examples. Uh, just a note here, make sure to have some of these diagrams when working with a series of Cisco switches. In this case, this diagram applies to the Catalyst 9000s. In this case, we can see that we can use marking in the ingress direction. That means that we can apply marking commands to policy maps that are applied in the input direction. This diagram also is telling us that we can use marking commands included in policy maps that are applied in the output direction. So sometimes you can apply commands, but once you want to apply the policy map to an interface, the operating system will yield an error if this particular set of commands and is not supported in a particular direction. So make sure to have one of these diagrams. So let's talk about marking. Marking are just establishing numbers within packets as they arrive into our network. So remember that if you have a network, you have an imaginary line here, boundary line here, that we call the trust boundary. So flows will arrive into your trust boundary, and you are not willing to trust the markings that these packets already have. So you want to remark them with an appropriate number that makes sense to you. So for instance, we can have a packet here that arrives and it happens to be a Zoom video packet. So we might classify it successfully and mark it with a value that we are going to say, for instance, that will be AF41 for video. Then this packet might arrive here and it can come, for instance, from a video phone. So we might say that it is an allowed video traffic for our corporate and enterprise policies, and we can mark it. So we can mark it with AF41 too. So, but let's imagine that we have traffic that arrives from the internet, and it is YouTube video. In this case, our corporate policies establish that this kind of traffic is not actually an allowed video or supported video traffic within our enterprise. So we might want to mark it with a value of 0, for instance. That means that it is best effort traffic, and we are going to provide more resources to traffic marked as AF41 than the resources that I'm going to provide to best effort traffic. So that is the point of marking, assigning some number to traffic so you can identify it later on when it is traveling across your network. Now, what kind of numbers can we use? For instance, for layer 2 markings, we can use QoS that is usually 3 bits wide for ISL protocol and for the AO2.1 QoS/P protocol. So we have 0 to 7 values. And for layer 3 marking, we can use IP precedence that provides us with 3 bits as well. So we can go from 0 to 7, or with DSCP that actually provides us with the capability of using 0 to 63. Although we are going to see that DSCP provides less available values. We also have MPLS, EXP for quality of service markings. That also is a 3 bits field, so we can use the values 0 to 7. This means that we can mark or differentiate traffic in as much as A levels when using MPLS, A levels when using QoS, A levels when using IP precedence, or up to 64 levels when using the DSCP. And these are the official names for these levels for each technology. For instance, for AO2.1 QoS/P traffic, the video traffic is said to have a number 5, for instance. But for IP precedence, video is said to be classified as number 3. So these numbers have a meaning for your enterprise. For instance, I have seen that in real networks, voice over IP is usually assigned the number 5, and video is usually assigned the number 4, but it is up to you what these numbers actually mean. And this is the DSCP table. Notice that we have 64 values because we have 6 bits available. However, notice that the least significant bit is usually 0. So the DSCP standard actually allows less than 64 values, but you can, however, use the 64 levels if you want to, because you have 6 bits available to you. Now let's go actually to the Cisco features. Cisco offers you these features in order to actually mark traffic. You can use packet header marking. That means using layer 2 header. For instance, you have trunk interface here. You can use QoS marking, which is layer 2 header marking, or you can use layer 3 markings, for instance, IP precedence or DSCP. What is the advantage or disadvantage of any of these ones? For instance, the DSCP and IP precedence is marking that works from end to end. And the QoS markings only works with trunks. The other new feature that we have in Catalyst 9000 is that we can use something that is known as switch-specific marking. Notice that when you're using QoS, you have 2 devices that will share the QoS marking. For instance, this device and this device. However, when using switch-specific marking or quality of service groups, the marking only exists within one switch. So this marking only is significant to one single device. As traffic enters the device, you can mark it with a particular quality of service group, but that information only lives within this device. So remember, we have packet header marking and switch specific marking. Now, when it comes to actually assign a number to the or mark, we have two options here. We have conditional marking and unconditional marking. With conditional marking, we're going to use polysync. So we have to use the police command, and it will depend, the value that we are going to assign to the traffic depends on whether the traffic conforms, exceeds, or violates. Remember that when you use police, you can establish a committed information rate, or CIR, and a peak information rate. So for the traffic that complies with the CIR, that means that is the rate is below the CIR, we are able to mark that traffic with a particular value. For instance, we can set, for instance, that traffic that conforms, we're going to mark it with a value of AF41. Now, for the traffic that exceeds the CIR, but it is below the PIR, that means that it is exceeding traffic, we are going to mark it with a value of AF42. And for the traffic that violates, that means that goes beyond the PIR, we are going to mark it with a value of AF43. This is known as conditional marking. And this type of marking was the only type of marking that was available in Cisco early switches. The other type of marking that we have is unconditional marking. That means using the command set. So with the command set, I can say that all the traffic that has been classified is going to be set to value AF41 without conditions. So this command set was not available in early Cisco switches. So it is actually cool to have this command right nowadays. Now, so when using conditional marking, I can use the conform action, exceed action, or violate action. Now, with for conforming traffic, I can use or set COS for layer 2 markings, and I can also use set DSCP or set IP precedence. I can also use MPLS EXP. For exceeding traffic, I can do the same, set layer 2 markings, layer 3 markings, or MPLS X. The same for violate action. Notice that I can choose not to mark the traffic, but to drop it. Now, for unconditional marking, I use the command set. That is a more easier to understand way to mark traffic. Now, we can use something that are known as table maps. This is a new feature, a relatively new feature. So with table map markings, we can create tables where we can establish a from value and a to value. So with these tables, the from value can go from 0 to 99, and the to value can go from 0 to 99. This is enough space to be able to mark, to reference COS values, IP precedence values, and DSCP values, and quality of service group values. Remember that COS go from 0 to 7 maximum, IP precedence go from 0 to 7, DSCP go from 0 to 63, and so on. So 0 to 99 is enough. So we can use these tables in order to map COS values to DSCP values, or IP precedence values to DSCP values. So we can play with that, and we can or we are able to jump from one type of marking to another with these conversion tables. This can be applied to ingress and egress traffic. So with table maps, we can do mutation. That means changing the DSCP to another DSCP value. We can rewrite values. It is good for mapping, so we can map, for instance, as we already say, COS to the DSCP. And there are little things to remember. For instance, remember that for ingress, table maps are going to work a lot with trust settings. So we are going to use these two features hand to hand, and they will help you when setting values for traffic that is entering your switch. So remember, table maps work together with trust settings. If you are going to trust anything else than DSCP, remember that they use an ingress table map with the copy feature. We're going to see an example of this. And for egress, if you're using quality of service groups, make sure to have a table that will do quality of service group to DSCP mapping and quality of service group to COS mapping. Okay, how do we create table maps? We are going to use the command table map and then the name, and then we are going to create the mappings. So I can create a map, the from value and the to value. Remember that these values can go from 0 to 99. And then we can apply the table map with one of these commands, for instance. In this case, for instance, we are going to say that the to value is COS. In this case, the to value is quality of service group. In this case, the to value is precedence. Because when you build a table map and you read it, you know that you are creating a table with a from value and a to value. But when you create a table map, you don't really know if this from value is referring to COS, or it is referring to IP precedence, or it is referring to DSCP, or it is referring to quality of service group. You don't know that. You know that when you apply the table map to a command. So that will be the end of the theory. Let's go now for interpreting quality of service configuration commands. So this is the first example. We have a policy map here. Notice that this policy map has this name, and we are using this name to apply it to an interface. And in this case, it is an input. So we are talking about traffic that is entering some port within your switch. And this policy map has three classes, three class maps: DSCP 20, DSCP 21, and DSCP 22. These names are actually a bit silly. They don't tell us too much. They are just random names, and they are related to the match that we are using. Now, this is the classification stage, and then we are going to use the marking stage with the command set, for instance. In this case, this class is using unconditional marking. Remember, unconditional marking is using set. So this particular example is telling me that traffic that arrives with a DSCP value of 20, we are going to remark it with the value AF 11. And in this case, this second class is using conditional marking. So in this case, we are creating a policy here with a SIR value and a peer value. And we are saying that for the traffic that is conforming is just going to get transmitted. So we're talking about DSCP 2021 marked packets. So the packets are going to keep the value of 21. We are just going to transmit them. But for the exceed packets, we are going to apply this table. We don't know the contents of this table, so we don't know what is the exact new value that we are going to apply, but they are going to be remarked. And the violet action says drop. So for all the traffic above the pier, we're going to drop it. And the third class is using unconditional marking. We are going to use the value AF11. So I hope that makes any sense. So we have another example here with conditional marking. So we are using policy here, using SEER. We are not using peer, only SEER. So what we're saying here is that the conform action will set these three values. So for the traffic that conforms, we are going to use a COS value of 4, a DSCP value of AF41, and an MPLS EXP value of 4. And for the traffic that exceeds, we are going to drop it. Okay, let's go for the next example. In this case, we're having a policy map here that has two classes. In this case, we're using unconditional marking because we're using the command set, and we are using unconditional marking here because we're using the command set. We are also using the police command, but that can live alongside the set command, and we are not using the police command in order to mark traffic. We are using the command set. This is another example of how to create some class maps that will be later be used to create quality of service groups. So this means that if you had a switch here, then all the voice traffic that is entering your switch will be assigned a quality of service group of 10. And for instance, for all the video traffic that is arriving into your switch, it will get assigned a quality of service group of 20. This is an interesting example of how to use table maps. In this case, notice that this policy is going to be used in the output direction. So we have here a port that is going to be connected, for instance, to an AO2.1Q/P trunk. And what do we want to do with this example? Notice that when your packets are traveling inside your switch, they have a DSCP value. So for instance, let's say that this packet wants to leave your switch and it has a DSCP value of 0. Then you need to let this packet leave your switch through this trunk. But remember that given it is a trunk, you're going to set up here a cost value. You need to set up a cost value. What cost value are you going to assign to this frame when it leaves your switch? Then we're going to use this table map in order to figure that out. This table map here is using a from value and a to value. When we apply this table map, we are saying that the from value is a DSCP value, and the to value will be cost. So when we apply this command, now we know that the from value is DSCP and the to value is cost. Now let's say that this packet has a DSCP value of 0. Then we are going to look into this table map, and we notice that 0 has an equivalent of 1. So we are going to write this cost value of 1 because the table map is instructing us to do so. Let's think that we have another packet that wants to leave our switch, and this packet happens to have a DSCP value of 2. So we are going to transmit this frame over the trunk, but the question is what cost value I'm going to use. So I'm going to go to the table map, and I see that the value of 2 will be mapped to a value of 3. So I'm going to use the cost value of 3 here. And let's say we have another packet. In this case, this other packet happens to have another DSCP value, let's say AF11, and it wants to leave my switch. So I have to transmit this packet over this trunk, but then the question arises, what cost value am I going to use? I will go to see this table map, and I will notice that there is a default of 4. This means that for every single DSCP value, that is going to get translated to a cost value of 4. So I'm going to write down here a number of 4. Hope that makes any sense. In this case, we have something similar. In this case, we are going to see what happens if I have a port that is connected to a trunk here. And so we are using AO2.1q/p protocol, and I am trusting DSCP. So for every single packet that arrives to my switch, I am going to examine the DSCP value, and I'm going to use it. So I am going to store this DSCP value, and I'm going to set an internal cost value to 0. I am not trusting cost, I am trusting DSCP. So I only will take notice of the DSCP value of this packet that is entering my port. But what happens if a packet enters my port, but it is a non-IP packet? If it is not an IP packet, what is the DSCP value that I'm going to trust? That is not a DSCP value, and I'm going to set the internal cost to 0. So I want to preserve some sort of information, so I'm going to preserve the cost value. So I'm going to use a table map. Notice that this table map says default copy. So everything will be mapped to everything. In this case, this is the from column, and this is the to column. I am going to use this table, and I'm going to say that cost value is the from value, and cost is the to value as well. So at that moment, I know this table is going to be cost to cost. So what I am saying with this command is that the cost that is arriving along with this packet that I'm going to call the external cost, for instance 5, is gonna be copied into the internal cost. So I'm not going to set the internal cost to 0, but the internal cost will be set to 5. I am saving the cost. So in this case, we are trusting DSCP, and we are also trusting cost. Hope that makes any sense. This is actually an interesting example. We are setting up here a policy map, but we don't know whether this policy map is going to be an output policy map or an input policy map. Notice that we are using shaping. So since shaping is only available in the egress direction, I can safely assume that this policy map will be an output policy map. So what I'm going to do here is going to use a table map that is now DSCP to DSCP that is going to do copy. So I am going to use the internal DSCP value that packets have when they want to exit my switch, and I'm just going to use the same DSCP value from these packets once they leave my switch. Hope that makes any sense. In this case, we have another example of conditional marking. In this case, I have a zero value. I have a peer value. And I am saying that the confirmed traffic will be just transmitted. So no remarking here. Now for the exit traffic, I am going to use this table. So I am going to remark here with this table. And for the violet traffic, I am also going to transmit it, but I am going to use another table in order to figure out what are the new DSCP values that are going to be used for this remarking. Okay, that are all the examples I have, and this is a note for all configurations for all switches. This is a bonus information. Just an explanation here for catalyst switches have always used something that is known as the internal DSCP. So when traffic arrives into your switch, Cisco is actually going to figure out an internal DSCP value for every single packet or frame that arrives into your switch in order to do many quality of service processing. So even if this is a pure layer 2 port and this is a layer 2 port and you are only receiving frames, you still are going to figure out an internal DSCP value for catalyst switches. Bear that in mind. So we're going to use DSCP maps. We're going to explain what that is. These are maps that have existed in Cisco switches for a long time. They exist by default with default values. You may change them. And these maps exist because Cisco switches use an internal DSCP value for its inner quality of service processes. So every single frame that enters the switch will have an internal DSCP value. So for instance, we have a table that is known as the cost to DSCP map table that is used, for instance, when the traffic enters your switch and you have a cost value and you want to use this cost value to figure out the internal DSCP value. So this will be the mapping that will be used to map this incoming cost value into the internal DSCP value. You can change this table, and you can also configure something that is known as DSCP transparency. When you ultimately want to avoid your DSCP value that exists within your packet to never be rewritten after all of this quality of service process happens. So you can use this global command to avoid your switch from rewriting your DSCP value from packets that enter your switch. You can also use these commands an interface level. So this is a command that works for a global at global level. This command works at interface level. And what happens if you are trusting IP precedence? So you are trusting IP precedence. Where are we going to figure out the internal DSCP value that we have been talking about? We are going to use this IP precedence to DSCP map, which happens to have these defaults. You can change these defaults with this command. Now, when your traffic is actually entering the egress part of your process within your switch, you need an internal cost value. That is going to be the result of an internal DSCP value. And then you're going to need a DSCP to cost table. This is the default for this table, and this is the way you can change it. This is an example of how to change this table for a particular cost value, and this is the complete DSCP to cost table. The way that you have to read it is that you have to assign this grid with DSCP values in your mind. So for instance, this corresponds to 0, DSCP 0. This next cell corresponds to DSCP value of 1, 2, 3, 4, 5, 6, 7, and 8. And you can go from that point forward. Then this particular cell corresponds to DSCP value 9, 10, 11, 12, 13, 14, 15, 16. So notice that, for instance, 16 correspond to the COS value 0. That is because we have used this command to say that DSCP maps to COS 0. And then moving forward, this will be 17, 18, 19, 20, 21, 22, 23, and 24. Notice that 24 correspond to COS 0. And that is because we have used this command to map the DSCP value 24 to COS 0. Then we will continue with 25, 26, 27, 28, 29, 30, 31, and 32. Notice that 32 correspond to value 0, and that is because we have issued this command where we are mapping the DSCP value 32 to COS value 0. That's it.